Let's take a look at endothermic and exothermic reactions. A lot of times people get kind of wrapped up in this and confused in this, and I want to try to make it as clear as I can. Now, an endothermic reaction pulls heat from the outside and internalizes it, and it feels cold to the touch. An exothermic reaction pushes its energy out. It releases heat and feels hot to the touch. So some ones you might be familiar with are the hot hands for the wintertime, or a cooling pack. Both of those utilize chemical reactions to produce heat or to absorb heat and make it feel cold. Let's take a look at these from an internal or a molecular view. When we're talking about an exothermic, exo, exit, heat is released. The surroundings temperature rises due to the release of the thermal energy. This extra thermal energy comes from the conversion of the chemical potential energy and the reactants into kinetic energy to form heat. During the course of this reaction, existing bonds are broken and new bonds are made. We're going to see this when we start calculating energy and how those values are determined. The products of the reaction, and this is really important, have less potential energy than the reactants because it's giving off that energy. The difference in the energy is the released heat. Now, anytime you go from a more, let me say this the right way. If we're going from something that's unorganized to organized, okay? So for instance, if we look at phases of matter, if we have a gas that is less organized than a liquid, because the gas particles are all spread out. The liquid particles, though there's some fluidity there, they're connected, okay? So it's more organized. Anytime we go from less organized to more organized, we have to give off heat or give off energy. So if you think about this, if we're giving off heat, okay, this is exothermic. So if this is the case, condensation and if we go from a liquid to a solid, we're getting even more organized, and freezing, because that's what we're doing when we're going from a liquid to a solid. Both of those things, which seems almost counterintuitive, are exothermic. Okay. Likewise, if we look at an endothermic reaction, the temperature is going to drop due to the absorption of the thermal reaction. The products have more chemical potential energy than the reactants. Okay. It has to pull energy from the surroundings to make this happen. So if we're going from a more organized to a less organized, so say we're going from a liquid going to a gas. Okay, we have to pull those particles apart. To pull those particles apart, we have to put in energy. To pull apart the particles. If we put in energy, that means that vaporization as well as melting are endothermic processes or reactions. That's kind of a weird thought, okay? But it does make sense because remember, our bodies sweat. The sweat evaporates, unless it's Henderson in the summer. And because it evaporates, it cools us. Ah, endothermic, okay? Take a moment, try these in the examples, and then we'll see if you're right or wrong. Actually, I gave you the first one, but try them. Okay, welcome back. So, evaporating, as we said, would be endothermic, okay? So water freezing, it's going to have to give off heat, is exothermic. And wood burning would be exothermic. Now, if something is endothermic, we're going to give it a positive, and we just introduced a new term, and I apologize that I didn't say something about that sooner. Delta H. Delta H, H is representing enthalpy. Enthalpy is like delta E at a constant pressure. For our purposes, pressure. For our purposes, we're going to treat them the same. Okay, so delta H, enthalpy, heat transfer. Don't get too hung up on it, but you do need to know that delta H is enthalpy or enthalpy, depending on what part of the country you're from. Okay, so a positive delta H is endothermic. A negative delta H is exothermic. If we look at the bottom, very similar to before, if we're melting, we're going to a less organized. So that's going to be an endothermic or positive delta H. Evaporating, endothermic, positive delta H. And burning, exothermic, negative delta H.